Okay, so my name's Angie Gabler. I'm with STRATA Architecture. We've been doing work here in Excelsior Springs. Well, I've been working here off and on for about 17 years on different projects with the Hall of Waters and projects downtown and for private clients. We've done work here in the Hall of Waters, multiple projects in the districts around here at the Elms. And before that, Susan Richards Johnson, who was my business partner, has been working here specifically on the Hall of Waters, I think since like the late 80s, early 90s. We've had a really long history. I kind of feel like I'm home here. I love coming to Excelsior Springs. I love getting to know everybody and seeing the progress that goes on here. So today I invited Corey Thomas to be with me, and I'll let him talk a little bit about what they do.
Yep, I'm with Pishny Restoration Services. We are a self-performing general contractor that specializes in just historic restoration work. Everything from foundation stabilization through masonry walls, whether it be brick, limestone, terracotta, granite, as well as plaster on the interior, historic stucco on the exterior, and also a tremendous amount of window and door restoration work as well, whether it be wood or steel or stained glass. Really, if it's anything but mechanical, electrical, plumbing, and it's on a historic structure, we do it. And we do it with our own forces. So we don't subcontract any kind of work, anything like that. It kind of gives us better control over schedule and quality and things like that. But anyways, I'm glad to be here.
So today we're here to talk to you about masonry maintenance. So, we're going to talk more about brick and stone, maybe touch on cast stone a little bit. There are other types of masonry we're not really going to get into today, like glass block, terracotta, different types of concrete units. But today, like I said, we're going to focus mostly on what we see here in Excelsior Springs, which is really more brick and stone. And this is meant to be conversational, not a lecture, so I want everyone to be very interactive, ask us questions, don't wait until the end. If we've got a slide up and you don't understand something or you want to know a little bit more information about it or talk more, just ask and let us know. The idea of maintenance isn't something new, but maybe just thinking about it as a preventative type of aspect as opposed to just waiting until something's wrong is kind of what we're going to talk about today. So historic homes and buildings should be treated with respect. Obviously, we know those that are taken care of last a lot longer than those that don't. The work that we typically propose for maintenance and restoration on historic buildings all meets the Secretary of Interior's standards for the treatment of historic properties. And that's something that we've talked about a lot with the Historic Preservation Commission, the design guidelines here in town, and those types of things. Those are kind of the standard rules that the National Park Service has put together to test any work that you're doing to a historic building. Everyone involved in the maintenance of historic buildings, that includes owners, people that live in the buildings, and the contractors, should be aware of what's important about the building. So what are its character-defining features? Making certain that maintenance of those original features is very important, and trying to, I guess, make certain that those are being inspected on a regular basis. And we've put some different project pictures and things in here. This is actually a picture, I think I've got it here, right? On the right-hand side of the Iowa Soldiers and Sailors Monument that Corey and I worked on together 10 years ago?
Yeah.
This is right outside the Iowa State Capitol in Des Moines. So maintenance, actually the definition is to be, it means that it's the continuous protective care of fabric and setting of a place, and it's to be distinguished from repair. So the idea of maintenance is you're maintaining something rather than having to repair it later. So repair involves a restoration or reconstruction.
And when we say fabric, we're not talking about fabric.
Yeah.
We're talking about it could be any kind of historic material, right? It's a phrase that we use often.
Right. So maintenance is most beneficial with regards to conservation because less historic fabric is lost if you're doing regular, minimal, and small-scale maintenance work, and tends to be less disruptive than waiting until you have to do extensive repairs. It's obviously the best way to look after your historic building is to actually just do maintenance. Practicing maintenance on a regular basis will prevent a lot of very large failures and repairs in the end. And in order to do that, that's proactive. Sometimes you have to think about, I need to probably just go out and walk around. I haven't looked at things lately. Doing a regular walk around your building is very important.
Is there a certain time schedule that you say you should do that? We often recommend
Yeah.
spring, like just coming out of winter and then going into winter.
Right, and definitely
So
looking at
twice a
critical areas, like making certain your downspouts are cleaned out and, all those typical basic things, but look everything over. I think it's easy to get, put on the blinders when it's your own home, because you've looked at it for so many years, or your own building because you've been there for a long time. I'm guilty of it too. I'll walk outside and 9 months later, like, oh my gosh, where did that hole come from? I've got one in
It's
my
kind of like me
yard.
looking at a picture of myself 10 years ago. Oh my gosh, what happened? It's kind of the same thing.
But like what we're saying, if they're neglected and you're not looking at those things, then defects can occur that can result in, bigger projects, and sometimes unavoidable, irreparable damage that can cause permanent issues, and it can also cause safety hazards. This is wood needs. This is a project that Corey and I are working on right now, treating from my office. And we all know water is a building's worst enemy, right? So if we can keep the water out, we tend to stop or mitigate a lot of those deterioration issues. And water can come in through a little tiny crack. It doesn't have to be big. It can be in areas that you can't see where flashing has failed, where mortar has failed, where a pinprick in a roof, all of those little things. So while a facade's meant to be pretty, it's also meant to protect the building. So if you're not protecting water from getting in the facade, you're not going to protect the building, right? So it's it's the number one thing that you need to look at besides your roof. So thinking about what happens, when it rains. I love this picture because he looks like he's frightened of the wall, and he should be. He literally leaned over after taking this picture and pulled a brick out of the wall with his bare hands. That's how bad the mortar was on this wall when they started. And when we started this project, they actually said, well, I think that wall's fine. I don't know that we need to do anything to it. The owners did. And we took the contractor back there and proved that literally could deconstruct this wall. The mortar had become so soft over time that you could just pull the bricks out by hand. So, there's maintenance work that you plan, and then there's maintenance work that you don't plan. And by planning for it, looking at those things short term, hopefully it will make things easier if there is unplanned work. So unplanned work are things that are emergency repairs, like from a storm, some kind of damage. One time I had a client call me because a bus came through their building. Things like that happen. But I think that the bus driver tried to say the building ran out in front of it.
Of course.
But there are a lot of things, and specifically for here in the historic districts and Excelsior Springs, that you might think about before you start maintenance on your building. One thing that's really important is to know whether or not your building is listed in the National Register of Historic Places. If you're in a district here, you automatically are either a contributing or non-contributing building in one of those districts. There are a few homes here also that are outside of that. And then understanding what types of reviews are required for the type of work that you're doing. Basic maintenance doesn't usually require a whole lot of review. You could typically walk in and get those approved, kind of an over-the-counter type of approval. Anything that's more extensive, if you're replacing materials, is going to require a certificate of appropriateness. So understanding what the scope of your project is, just call the city and ask, and they'll help you understand what the application is supposed to look like. And who's going to be doing the work? Is this work that you can do by yourself, or is this work that you're going to be hiring to a contractor? You want to make certain that your contractor gives you references, that they are familiar with the scope of work, that if you're working on a historic building, that they know what they're doing with the historic building. Ask the city for references if they know what projects they've worked on. If you don't know, ask your neighbors, ask them for people to call, and go look at their work and make certain that you're happy with it. Typically, masonry is not something that you want to take lightly. It's one of those, it's fairly permanent, maybe something you only do once in your lifetime, and you want to do it right. So definitely go out and look at examples of work. You don't want to have to redo the masonry work, and you don't want any harm to come to your building with an unqualified mason.
It's structural.
Absolutely.
It's not just cosmetic.
And be sure that once you've hired a contractor, that you tell them everything you've done to the building. So if you've put sealers on it, or you've done other types of corrective measures that haven't worked, let them know what you've tried, and be very open about what the maintenance record kind of looks like on the building to date. So one of the other questions that people ask me a lot are, what do you mean a multi-wife wall? So I thought we would talk about that a little bit. Historically, walls were built like the 5 images that you see down here on the bottom, where we call them multi-wives. This is a single wide brick, so you can see it's 1 brick deep, and then there's some bricks with headers this direction. And then you get into multi-wife, where this might be 2 to 3 or 4 bricks deep. And then we say that that's a 2 brick deep wall. They're calling this a 1 brick wall, but it's a 2 wide because you can see, you know, the headers are going this direction. So you might end with the 3 sub-buildings on the first floor or 4. Then we've got a rubble wall, and basically what that means is we have rubble kind of everywhere, you know, different sized stones, it's not really dressed. And then we have a rubble wall with a brick backing. And so we see this a lot in buildings from the 1800s where you have a rubble wall, this gets laid up, and then the stone's kind of a veneer as they're laying it up, and they tie it into the rubble wall. And then this is more of a dressed stone with a brick backup, and then a rubble wall with the stone backup. So these are just different types of what we call load-bearing masonry walls. And so you can have those on the outside of your house, and sometimes you can have them on the inside of your building as well. So they're not just an exterior. Sometimes you might find a combination. We find a lot of these types of walls here, where the backup on the inside is actually clay tile, and you may have brick outside, or clay tile with stone. So there's a lot of different ways to look at it, but what's really important is to know what type of wall you're dealing with, because each one of these works a little bit differently. In contemporary construction that you're going to see more in the 20th century, a little bit turn of the century, but more in the 20th century, you're going to have a wood frame building, that's what's back here, and then an air space, and then a veneer. And that veneer could be brick, or it could be stone, it could be a combination of brick and stone, but this is not a load-bearing masonry wall. This means that this is just for pretty, it's to keep water out, but this is the structure back here. And so if somebody tells you I have a stone veneered wall, that's what they're talking about, or a brick veneered wall. And they behave very differently, and they need to be maintained differently. So if you can imagine, you know, you've got air vapor in your house, water vapor coming through, people breathing, you're taking showers and doing all of that. This wall acts very differently than this wall will. So understanding how moisture moves through the wall and what the interior finishes are. Most of these, you're going to find that the plaster surface will be directly applied, like in this case, probably right here on the interior of the wall. And in this case, it would be on this side, and on this case, on this side, where they might plaster directly onto the stone or the brick on the inside. Occasionally, you'll find maybe a metal lath with plaster on it, but that whole mass acts as a unit together. Whereas this, as a vapor barrier, this black right here is a vapor barrier, so that stops the moisture here. So the idea here is that you don't want moisture to get back behind here, and if it does, it needs a way out. So they're designed very differently. If somebody tells you they're going to put a weep in one of these walls, it won't do any good, but it will here. So.
Can I elaborate on that just
Yeah,
a little bit?
please. Yeah.
So another way of saying it is that, so a mass masonry wall, especially in today's buildings, say they were built in the late 19th century, there was no air conditioning. Now we take those buildings and then we air condition them. So now we have cool, dry air on the interior, warm, moist air on the exterior. It's kind of like walking outside with that glass of iced tea. Just all of a sudden the outside is just full of condensation. Well, that happens in that wall all on its own, somewhere in that wall.
Wow.
And,
it has a dew
we'll
point
talk
in the
about this
wall.
more, right?
Yeah.
There's a dew point in there. And so that moisture has to have a way of getting out. And typically will evaporate to the interior through the plaster, which is very breathable. Historic plasters were high in lime. And then also to the exterior through the mortar joints, which was also, they were mortars that were very high in lime and very breathable, vapor permeable.
That wall we showed you where you could pull the bricks out is because the mortar was nice and soft. It did its job.
It was exhausted.
Yeah.
The binder did its job, it was perfectly fine, and the bricks were in fairly good condition. Now, the modern constructed wall here, the way it handles moisture is by just trying to keep it out.
Right.
But as you know, you just can't always keep it out, so they have the backup behind it that will allow water to then go down, hit the bottom of that wall cavity, and come out through weeps and ways you, if you don't know what she's saying there, it's the little cords you'll see coming out of masonry walls, little holes, or flashing sometimes.
I went and looked at a solid stone wall the other day, and the guy had put a weep at the top of the wall, and I still can't figure out why.
There's no reason for that,
Yeah,
right?
it's bizarre. Again, it's hiring a mason that knows what they're doing with these types of things. So the other thing to think about too is, how is your masonry wall wearing? What are the issues? And understanding which type of construction is going to tell us a lot about what's wrong with the masonry. Can it be repaired or restored? If there are replacement units required, what type are they? Are they brick? Are they stone? Are they handmade brick? Machine-made brick? Different types of brick? The same thing with the stone. Does it have a texture? Do you know what a quarry or where it came from? So there's lots of questions to ask. So maintenance, the philosophy of maintenance is to repair rather than replace. So the idea of continuous maintenance is that we're doing less repair, but we're having to do replacement later. If replacement is required, we always say do an in-kind match, and what that means is that if you have a brick, you're putting a brick back in, but the brick is going to be the same hardness. If it's a machine-made brick, you're going to put a machine-made brick in. If it's a handmade brick, you need to put a handmade brick back in, because they all act together as a unit and as a system.
Angie, how do you know what is a man-made brick and what is a handmade brick?
So a machine-made brick is going to be harder, and they're going to have more of a fire skin on them than a handmade brick. The handmade bricks,
They'll also be very uniform.
yeah, they'll be perfect edged, very square, whereas the handmade ones are pressed into molds. They tend to have softer edges, and the graining pattern, the graining inside of that clay tends to be a little bit more visible. Sometimes you'll go by and see a handmade brick house, and there may be variations in color, and that comes from how the brick was fired and how close it was to the fire when it was put in there. So that tells you a lot about the type of kiln they used versus a big machine, commercial type of kiln where they're firing bricks too. But it is really important to do the in-kind because and we'll show you some pictures of some that don't match, and you'll understand why not only does it look bad, but it functions differently in the wall. So in-kind is really important. So we're looking at the material composition, design, color, texture, and what it looks like. A substitute material can be used. Sometimes we find the materials just aren't available anymore, or we really don't know where it came from. And especially with stone, you'll find we don't always have good records or documentation on where something was quarried. Or we may find that the stone that was used, and we know where it wasn't good in that type of use. We have stone that's quarried in Missouri, known as Carthage marble, that is really a horrible thing to use on steps. So nowadays, we don't put that back on steps. We may replace it with an Indiana gray limestone or something that's similar in color, but it's going to have a very different performance. Whatever we do for in-kind should be reversible, meaning later, if we find a better product, we pop it out, put the new one back in, to not create any damage. If you're doing too many substitute materials, you do lose authenticity, and that's really important for historic buildings where, if you're having a facade issue on a major part of the building and you're replacing more than 50% of it, you don't really have the historic fabric there anymore. You're losing the original integrity. So that's why that maintenance is so important up front. Inappropriate substitute repair materials can cause severe and irreversible damage. And we'll talk about some of that as well. That can come everywhere from mortar, incompatible mortar that's too hard, incompatible patches, bad flashing, not leaving weeps in a wall. There's so many different things that you can do to really, make bad repairs and bad substitutions that can cause damage. And then always check, like I said, with your local review board to make certain that you're doing everything that's in kind. Just real quick, I was going to touch on a few typical issues you'll see when you're looking at a brick or a stone building. We've got cracking, smalling or lamination, chipping. Sometimes this happens when your mortar's too hard and the stones don't have enough room to move, or it can happen if you don't have an expansion joint in the wall and the stones don't have enough room to move no matter what. Patches, previous patches, we have rising damp that comes up from the ground, missing mortar where you have open mortar joints, and sealant. People don't really think about this as being part, but it's part of the masonry system. There are places where it's appropriate to use sealants, and there are a lot of places where it's not appropriate to use sealants. We can touch on that maybe a little bit later. In the 80s, everybody thought sealants were the way to go. They're going to last forever. They were taking mortar out of buildings and sealing up stone buildings all over Kansas City. And now we know, Oh, the Missouri State Capitol, they did a number on it.
100%.
Not appropriate for a stone building to be sealed with a sealant material. They don't breathe. Sugaring, this is something that happens a lot to that Carthage marble, like we talked about in some limestones and other marbles. Inappropriate mortar, this is an example of a project that Corey and I worked on, where they used a super hard Portland cement with a really soft native limestone.
You can see the mortar's in excellent condition.
Yeah, but the stone's wearing.
The stone is wearing.
Biological growth.
Should be the opposite.
So, you know, you've got all these little micro fissures in the stone and little pockets and things because it's a natural material. And you can get all kinds of biological growth growing into those. Most of it's not harmful, but occasionally it can be, and it can permanently stain. It can also have other growth. There's also atmospheric staining, which can be harmful to your building. Efflorescence. This is getting water in the wall, and it comes out at the base of your bricks. It's bringing salts and everything from the mortar or from the masonry material itself through. We've all seen buildings, you know, that have a lot of efflorescence on it. You can see it today when people build those big block buildings, you know, in the shopping malls where they have white patches all over. It's all efflorescence. And then metallic staining. And metallic staining can come from flashing. It can come from flashing within the wall, but it can also come from water in contact with the wall that has a lot of different contact with the water. So the metallic staining is something that we see. You have it out here in the Hall of Waters where the copper lights are sitting on top of the walls. That water comes down and gets in contact, and eventually that copper staining ends up on the stone.
We've seen people use wells for an irrigation system, and then it's hard water. And years of applying that, iron stains, calcium deposits.
And there's some stones that inherently have iron in them, and so you'll look at a building occasionally and there's rust stains coming down it, and it's just part of the natural stone. In kind, this is what we were talking about earlier, is where we're matching material, and you can do that with stone or brick. Replacement stone, you know, try to use the quarry where it came from. Terracotta brick, you may want to use reproduction or replacement material. When we're working on these, this is a handmade brick. When we're working on these types of buildings, this brick is really hard to find today. There are a few people that still make it, but it's a lot better to just go find a building from that same era that somebody salvaged brick from and reuse that brick. And I'll talk a little bit more about this project later, but that's what we're doing here, is actually reinstalling salvaged brick. When we're doing that, we always say, if you're going to take one out, put a full unit back in. If you're taking out a damaged unit, put a full one in and make certain it's toothed in. And what that means is, you know, if you take this brick out, don't put two little ones back in here. It should be a full brick so that it's all, you know, following the original bound pattern of the masonry that's in here. And then there's Dutchman patches, and we see this a lot on stone. This is actually the Church of St. Mary of Aldermanbury, which is the one that's down in Fulton. It's the church that was the 17th century church, the Sir Christopher Wren church that was dismantled and brought over here to the United States in the 1960s. And these are really old stone Dutchman patches that were actually done back in Europe. These could be hundreds of years old. So they've been doing Dutchman patches, is what we call them, for a really long time. If you go over to Europe, a lot of the churches still do these. Sometimes they'll even take the stone out, turn it around, and just patch a small portion of it. But this church, you know, went through pretty good bombing in World War II and wasn't repaired. So these, we know, predate. It can be clear back into the you know, 1700s or 1800s for some of these. And it was moved, and they put them. Wow. And then some of them are new from when they reinstalled the stone. Substitute materials are appropriate, you know, where original materials performed inadequately. So for one example is like that Carthage marble that we were talking about, where we don't want to use it any longer. But you know, you always want to think about, is it significant? Where was the material located? What is the level of deterioration? If I put it back, you know, is my substitute material going to last longer? Is it a life safety issue? Is it going to fall? We do find that sometimes that Carthage marble is up in really big overhanging deep cornices or soffits. It's not safe. Sometimes that stuff tends to delaminate and big chunks can fall off. Durability is important. Cost obviously is important. The availability of the materials, and also the environmental or economic impact. So this is all good, you know, to kind of think about when you're looking at substitute materials. Sandstone, you know, sandstone is one of those things when you all think about them, I always think of sandstone just kind of melting away. Eventually it tends to kind of break down and erode over time. Putting sandstone back on buildings is something we don't do anymore. We usually use a substitute material for that as well. This is a project Corey actually did all the initial assessment on this with me. This is Second Presbyterian Church. It's at 55th and Oak. And the top of it, it's hard to see here, but there's a band around the top of the tower here. And this band was put on 39 years ago as a temporary measure because the top of the tower had been starting to relax. And so we came in and did a study on this, looked at it to see what we could do, and got up here. It's hard to see on here, but all of these units that you see up here have been coated with a really thick cementitious coating, like a paint, thick paint cementitious coating. And what it was doing was hiding some massive cracking and crazing in all of these units. You guys see spider cracking everywhere in these. That's not a structural problem, it's an aesthetic issue. But it's one of those that if we started taking these apart to dismantle the tower, we knew we weren't going to be able to salvage these pieces. They were just going to crumble. So we, you know, took these pieces down. We took tons of measurements, had really good shop drawings done, and debated whether or not to put them back in cast stone. Right? So cast stone was something that when they built this tower, should start here. This was the top of the tower when they originally built it, and then about 40 years later, they added the rest up here, and it might be that the cast stone was just more economical at that point to finish the top, and they didn't have the money to pay a stone carver to do all of that work. Because you could use repetitive patterns, it's on all four sides. But today, you know, we have machines that can do a lot of this carving. Some of it's still done by hand, but looking at, you know, what are our options here? We go back with cast stone, we know we're gonna have issues with it later, versus going back with limestone. We were able to actually go back with limestone. Another part of this are the tracery pieces that are right here. These were originally done in wood, and over the years, the bases kept rotting out, and they just kept chopping them off. It also was a life safety issue. Some of them were hanging by like part of a screw. Pieces had fallen, you know, while people were at church and would come out. These were in very, very sad shape. And, you know, thinking about putting these back in wood was not a good solution. Not from a longevity standpoint and a maintenance standpoint, having to get people up there and paint them every couple of years. So this is another thing where we actually did substitute these, and we did these in a cast stone, but more of a synthetic cast stone, something that will last a lot longer than a traditional cast stone. So this is the pieces being made. These are the cast pieces for the tracery that go up here. And like I said, this is a synthetic product. And then these are the carved limestone pieces that actually go at the top of the tower. So we took the tower down all the way to this level and completely reconstructed it up on top and restructured up here with a concrete grade ring, essentially ring around the top of it to keep it from spreading out.
So Angie, a question on that. Are you required to number those stones so you know where they go back in at, or how do you make that work?
So a lot of these are new. They were able to salvage some. So remember that picture I showed you where you have a multi-wick wall? The outside pieces are what we call dressed and cut like this. And yes, they did reuse them. Essentially, they had really good photos. I wouldn't say it's exact, but they tried to keep this column, the stone here, you know, put it back in this column. The inside backup is all different. We actually did it out of CMU instead of rubble stone, which is what it was when we took it down. And that was part of the issue, was that rubble stone really doesn't have any capacity to take any flexural strength at all. So we were able to do, you know, at least make it look from the outside and hopefully give them something that's going to be a lot easier for them to maintain in the long term. And these are all that cast product. You guys, they look beautiful up close. They actually look like carved stone, which you would see in Europe and a lot of those types of churches. This is the Savoy downtown, and this is one where they used originally when the building was built. So you know, this was built 3 phases. The original building had sandstone sills throughout that all looked like this. Some of them were way worse, some of them you could stick your hands through. And replacing these was not an option with sandstone. We talked to the client about it and did not recommend that they go back with a sandstone. It's hard to find the right color. And if you do, you're going to be using salvage material that's already started to wear in the road anyway. So we actually suggested they go back with the cast stone product. So on this one, we worked with a local shop here to do custom colors on the cast stone sills and have those remade in a substitute product. And they're on upper floors, you can't tell, they look really sharp, and it's worked pretty well. That's the finished product. All right, I'm going to turn it over to Corey.
Real quick on the
Yeah.
cast stone.
Yeah.
So how does the National Park Service look at that substitute material to, say, the sandstone?
Yeah.
How do you communicate that with them?
We showed them, okay, so the Savoy, for instance, was a new hotel, it's 21C, and they did get historic tax credits for that project. So all of that work that we did was looked at by the local Kansas City landmarks, by the State Historic Preservation Office, and by the National Park Service. So we submit a packet of materials, we submit a full set of restoration drawings. I'll show you what some of this look like in a little bit, where we've done a full detailed analysis on the condition of the building. And we might go through and say, 60% of the sills, are sandstone, they're all eroded, a lot of them are coming apart. We don't think this is a durable material for substitution, and we will show them the actual substitute material, the color samples, what the detail looks like. And from a distance, nobody's going to know. We've never had an issue on that type of a substitute material where it's a durability or longevity type of thing. And once that's approved, then you're setting good precedents for asking for those things for other types of products. Does that answer your question?
Right. Well, and I just wanted to say that there are times when you can use a substitute material when the original material has proven to not really be a durable long-term solution.
Right. It's kind of like wood windows now. A lot of people want to use aluminum windows or an aluminum-clad wood window, appropriate in certain instances and not in others. So, each one of these is a case by case, and you're going to want to talk with the Preservation Commission and get some direction on how those decisions are made.
What's what on here? Great.
Yep.
Advance this one. Okay, great. Angie's handing over the easy parts to me. Okay. So being a contractor and using the materials every day, we're very familiar with mortars and what's appropriate for historic structure, what is not. We see the majority of the buildings that we work on have been repointed with some type of a repointing campaign over the last 60, 70 years with something that has a lot of Portland cement in it. And to understand how those different materials interact and how they change the way that the wall works, that's what these next slides are really about. So early mortar formulations, everything here really in the Midwest up until around 1910, right in that time frame, was lime and sand. That's all it was. There was no Portland cement added to it. Portland cement is the main component to concrete, okay? And we know how hard concrete is. So up until that point, that's really all it was. It was about a 1 to 3 lime to sand ratio. The lime had great vapor permeability. It breathed really, really well. It had excellent flexibility. So it was able to, in a wall that had no expansion joints built into it like they do in modern construction, it allowed that building to move a little bit through the temperature changes or even little tremors, anything like that. It was self-healing, meaning one day you may walk by and see a little bitty crack in your mortar, and you may get a rain event and it's gone the next day. I mean, so it was a really wonderful material and used for a long, long time. Now, when Portland cement kind of moved its way across the country, when we got here in the Midwest, masons really liked it because it didn't require a lot of babysitting. If I added a little bit of Portland cement to that lime and sand, it sped up the cure rate. It made it set faster. Whereas with a lime and sand mix, you kind of had to babysit a little bit, get a little mist of water here or there. Didn't want to dry too fast. The heat and lots of wind, dry wind and stuff like that would make it flash set and not bond to the masonry around it. So you had to really babysit it. Whereas Portland cement kind of allowed them to hop off the job a little bit quicker. Hey, this is great. And eventually it's like, hey, if a little bit is good, a lot is really good. Let's just keep adding and adding. And that's how we kind of got where we are today with what you can pick up, say, at your Home Depot or Lowe's. Very hard, pre-mix mortar mixes that are fine for modern constructed buildings, but not for historic buildings. But some of the aggregates that were involved with historic masonry, so you had lime and sand. It could be lime and crushed seashells, or sometimes they would add in brick dust to give it a color like a red mortar. You can see that. And often that was just accumulated on the job site from cutting the bricks. You could use that. And then also sometimes animal hair was added. You see that more often in plaster formulations or old stuccos than you do really in mortars, but you do see it sometimes in mortar. But the basic formulation remained the same. Portland cement, lime, and sand is kind of more of a modern mix. We do use in historic masonry some mixes that have a little bit of Portland cement in it today, but it still breathes really, really well.
I was going to say something about the sand too, is that sometimes it's it differs by locale, because a lot of the people, the sand companies get it from the rivers in the area. So if you have a specific kind of aggregate or sand, you know, here it may be a little bit different than what you get in a different state. So also kind of understanding what you're looking at, and when you get in and look at it, mortar can be really unique. You know, in the 20th century, we have some mortars that have really chunky, big aggregate sand in them.
Almost pea grass.
Yeah, like big pieces, and that was for aesthetics. You know, where. And then you get into the, you know, the late 1800s, and you might something that's really fine. And so, you know, really looking at what that aggregate looks like and copying that character. And a really good mason can source that sand from a lot of different places and get you a really good match on it.
Yeah, yeah, and that's really where your mortars get their color. So when you look at a building and the mortar on it looks kind of a tan or a buff color, what you're really seeing is the sand. You're not seeing really the lime or cement in the mix as much as you are that sand. So matching it is an important step when you do repointing. If you're not doing a 100% repoint of your building, you're spot pointing here, there, open joints, that's a critical thing to keep an eye on. You're exactly right. So sourcing it locally is usually your best match. So if you do have, like, I know it sounds funny, a little local stream that has a little sand bed in it or something like that, take that, rinse it out, get the dirt out of it, and you'll find it's usually a pretty good match, because that's what they had access to when the buildings were built.
So we did a project, we've done a few different ones over the years where you'll look at the mortar and it might have what we call inclusions in it, which could be chunks of lime, or it can have even like really dark specks in it. And we've, you know, I've always kind of heard that it comes from the riverboats and so with the coal, you know, spitting out of the steamboats onto the riverbed. And so we've added what we call black beauty into our mortar mixes to get a good match before. So there can be an art to it, and you know, it really can make a building when you go out and look at it to make certain that that mortar matches.
Yeah, and an inclusion, a lime inclusion will be you're looking at your mortar and all of a sudden you see this chunk of something about pea size maybe, that's just pure white, and you can dig it out with your fingernail. It's actually an unmixed portion of lime from the mortar mix. It just didn't get mixed in real well. And you're right, we've taken lime and we mixed it with a little bit of water and smoothed it out flat, and then let it dry, and then we'll crunch it up into little pieces and we'll throw it in the mortar mix at the end just to give it that same appearance.
One of the places you'll see it a lot are in basements, because the mortar drains tend to be really, really thick.
Huge.
And you can have huge lime inclusions in those, just really big chunks. So something to look for.
I told Angie this is portion is an old slide. That's my daughter on the far right. She's 17. She's 17 now.
Aww.
I think she was about 4 in that picture.
It works great.
Yeah. So Portland cement was patented in Great Britain back in the early 1800s and imported until it was first made in the U.S. in 1872. What widely used, we kind of went through a little bit of this. Early use was just a minor ingredient. Yeah, most masons used a 1-to-1 ratio of Portland cement and lime putty. Here's your water bottle. Here you go. That's yours. Yeah. But the mortar formulations in buildings between the late 1800s and the 1930s, it really can vary greatly. So that's why it is important to understand what kind of mortar you have in the building that was original, and try to match that if you can. And there's ways to do that. There's mortar testing. You can send a mortar off to be tested, and it'll tell you the exact formulation of your original mortar. Great place to find that is up in your attics, on the back side of your masonry walls, on your gable ends, because they're very rarely pointed up in there. But try to get it from deep within that wall, if you can. All right, mortar types. M, S, N, O, K, and L. That actually stood for, it's every other letter in the phrase Mason's work. So M, then you have A, and then S, and O is gone, then N, W is gone, O, then the R and the K. L is just a line mix that has no cement in it. You just threw that on the end of it. So, the most common used mortar today in buildings that were built in the late 1800s up into maybe 1910, 1915, right in there. We use a lot of typo mortar. That's just a little bit of cement in it to help with the set. And it also adds a little bit of durability, so you get a little bit of longer lifespan out of the mortar, but it still has a lot of lime in the mix that allows some flexibility as well. And most often, that can be purchased, by the way, from local companies. You can have it mixed from Ash Grove in a pre-mix bag, which saves you a little bit of time if it's a good match to your mortar they have color-wise, or Midwest Block and Brick in Kansas City. They will mix type of mortar. Sometimes they have it in stock.
And they will customize the aggregates for you.
They will customize the aggregates. They can, maybe not always colors as much as they will go like fine, medium, or coarse, so they can at least get you more aggregate, more the bigger aggregates. But they're both good companies to work with. We use Midwest Block and Brick probably most often. But, so the hardest is at the top, and then the softest toward the bottom in that mix. Type M would be something that you would use with a modern material, maybe below grade, something, a foundation, that you're repointing, that needs to be highly durable. Type S and N are usually used above grade on more durable materials like maybe granite or modern masonry, brick masonry. Or concrete block, like CMU, things like that. This kind of goes over the exposures, so it's a chart saying these are the different types of mortars you would use for the different types of substrates in different exposures. So sheltered would be like under a porch or somewhere that doesn't get a lot of severe weather for that specific type of substrate. Is this going to be available? Okay, so this spread or PowerPoint will be available to download like on the city's website or something. Is that right? Okay, great. So if we kind of go through some a little bit quick, you can always go back. Don't forget, you can ask questions at any point. So I know I'm not so good that you won't have questions. All right, function of the mortar. It is a structural binder, so it provides some adhesion to the masonry units, and is used to bed the bricks, and it also does account for sizes and shape variations, because the old handmade bricks were not perfect. So when you would lay up a wall, you really kept your level, not so much just with your bricks, but also your mortar kind of accounted for. You'll see in old buildings, you may have a 3/4 inch joint here, and then it might narrow down to 3/8 of an inch, and then back up again and down. And that's what mortar really accounted for, with some of those variations in the units not being perfect. To also be the weak link or a sacrificial material. So it's kind of like on your vehicle, you don't replace your wheels, you replace your tires. They wear and you replace those. It's the same thing here. The historic fabric of the building that's most important is going to be your stone or your brick. So we want to save that. Let the mortar weather away. To enhance the visual characteristics of the building, I kind of feel a little different about that. But I think that the mortar should go away, and you should see the masonry. Some people really like to get fancy with their mortar joints, and then it's kind of you walk up and that's what you see. But I'm not a big fan of that. But also to weatherproof the bricks while allowing the evaporation of moisture within the wall.
I was just going to say, I've worked on a few churches and a couple of buildings where they have penciling, which is taking another white kind of a grout line or mortar over it. So if you have really uneven mortar joints, they did that to kind of make it fancy. So sometimes they
made it look clean.
Right.
Right.
Very, very white.
Where's the pointer on this?
It's the middle button.
The middle button, oh, is that one?
Yeah.
Okay. I'm going to put on my glasses for this one. Okay, so we were talking a little bit about how these mass masonry walls breathe, that they're really designed to breathe out through the mortar joint. Okay, so on the left, we have a proper functioning wall. So this is the exterior of the wall cavity. So any moisture that happens, either through rising damp or from condensation within the wall cavity, or an open mortar joint or a parapet cap on top of the wall that has a busted joint, whatever it may be, moisture within the wall can then move through the unit into the mortar. So it's like a wick, right? And then it carries the moisture out through the face of the mortar joint. It can do that in a situation where you've used a mortar that is softer than the surrounding masonry and more vapor permeable than the masonry around it. You have the opposite effect right here. So consider this a type S mortar, one of the really hard mortars that's been used. Now moisture tries to move through that mortar joint. It can't. It gets blocked by the repointed joint. So this is repointing here. The mortar's only so deep. And it hits that, has to go up, and then it deposits, or tries to go out through the brick, but it's also depositing salts right there as it evaporates. Us guys that wear ball caps and we get all sweaty in the summertime, you see that salt line, right? Gross. Or on shirts or whatever. It's the same thing. So it's depositing salts, just like that, but every time it does that, it accumulates, and that is causing damage. You'll see, that's where you see the mortar joint that's in perfect condition, but the masonry on either side is just gone. And that's exactly what has happened.
And it also doesn't allow the masonry units to move freely like they would with a softer mortar. So combining with the fact that you've had a lot of moisture coming through and the expansion and contraction of this different than the mortar, that's where you tend to see spalls and cracks and erosion on the stone or the brick. So those are the weak points.
That's a pretty good visual. It's a good one to refer back to. Mortar matching. So that's a great example of some nice mortar matching. Now, one of a couple things could have happened here. So, yes, the mortar color really stands out. However, it could be that they didn't rake back the joint and they just repointed right over the existing mortar, so it came out toward the surface more, and it probably grew in width a little bit as they did that. Okay, so that's one possibility there. Another thing that can cause that is obviously by not matching the sand. So you're just seeing, a light-colored silica sand or mason sand. Another thing that looks to me like a modern mortar mix that wasn't properly treated once it was placed. Usually you get it to a little bit past thumbprint hard, and we use something called a churn brush that we'll talk about here in a minute, that you actually you slap into the mortar, and it pulls off that paste face, that surface skim, that's cement and lime, and it helps to expose the sand, so it actually gives you a little bit of darker buff color. But the other thing, and it's a pet peeve of mine, I have a hard time talking property owners into, as well as the federal government on historic projects, is I want to clean this whole building first. Why am I matching dirty mortar?
Right. We go through this all the time.
Yeah, because this may match what's in that wall, but I wouldn't know it if I didn't clean it. So I'm literally matching dirty mortar if I was to do this correctly. But all that mortar looks dirty to me. All of that looks like it just needs cleaning. So you have a couple, so that's partial repointing. 100% repointing kind of gives you a new lease on life. You're doing the whole thing at once. The idea, though, would be to match the original mortar in composition and color so that you're taking it back to its previous glory. So that you're always in a great situation if you can do that. Spot repointing is a little bit more difficult. To do spot repointing, you should do an analysis of the mortar. We send it off. There's a couple different labs. Terracon will do it. You guys probably heard of Terracon. Highbridge Materials is probably one of the best. They're out of the Northeast. It may take 6 weeks to get it back, but he just does a beautiful analysis of everything from your sand, your lime, your cement, and he'll help you come up with a good mortar formulation. So if unable to determine the original mortar, use that chart that we showed earlier, which shows severity of exposure, type of substrate, and then that'll tell you an appropriate mortar for your building. Okay. talked a little bit about sand type and line inclusions a few minutes ago. Different types of tooling. It's a good idea to try to match that as well. You might see that there's been some spot repointing done on your buildings where they just came in and they just used a modern pointing profile like this one right here, or a weather, one of these two, usually this one here. But then you'll actually go around maybe the back of the building or somewhere that hadn't been repointed and you go, oh my gosh, you know, it actually had a beaded profile originally. So you have kind of an opportunity then to take it back to that. So take your time to do some investigation and see what was original.
And each one gives you a little bit of a different shadow line. I mean, they really are part of the character of the building. So like the raked joints, like that picture you showed earlier where the mortar didn't match.
Right.
Like the old joints look like they're probably raked
Right.
pretty far back, so it gives you a nice depth to that mortar. It's not on the face, whereas they repointed it, looks like they pointed it flush.
Right.
So it gives a very different character to that. The other thing we see a lot is that, if you'll go back to the beaded, we see that a lot on stonework. You'll see that raised joint that's really pretty, like a half round, and it can really add a lot of really great character. There's another one that's kind of, well, they call it, this one they call the grapevine on it, but sometimes they call it the grapevine where it sticks out and it's square. Everybody calls it a little bit of a different thing, but that character of that mortar is huge, you know, especially under stone foundations. If you've got a beaded joint, find a guy that can do beaded joints again. It really adds a lot of character. It tends to even out. You know, your stone tends to have mortar joints that can be really wide here, especially if they're not dressed stones. So you might have a wide joint and a narrow joint, and by doing that bead, it just dresses it all up and makes it look uniform.
Okay, so we talked about some of the terms. Repointing, that's just where you're actually going in, you're renewing the joint. We'll talk about some of the guidelines between how to do that. And then pointing is just the act of filling mortar joint during new construction. Repointing is actually typically the term in the restoration world or on older structures.
So this is a picture of the Arrow Rock Tavern. We're working on that right now, and they told me they had this great mason come in and he repointed the front of the building, and he did not repoint the front of this building in the 90s. If you'll look, what he did was actually slap some gray mortar in there
over it
on top of the old mortar.
And here's where you popped it out.
And it's popping out all over this building because it wasn't deep enough and it wasn't bonded. So, you know, they thought they paid a guy to do this great repointing job, and they were like, oh, he was a fabulous mason. And, you know, then we come back and we find this, you know, 15, 20 years later. It lasted for a while, it looked really good, but they also didn't rake the joints back enough. If you'll notice, the old joints were never flush like that. I mean, they were close, but maybe a little bit more concave. So it really changes the character of the building. You can see the color of the older mortar was a lot more tan rather than gray. But it's really sad to see this because this is something they've paid for once, they're going to have to pay for again.
Done properly, how long should it last?
It depends. If you're using a really, like an L or a K, maybe 15 years, you won't have to do any maintenance. But you're still going to want to spot check it because that does move around a lot. And these types of buildings move a lot. They don't have deep footings, you know, they're built over a piece of stone under grade. But a harder mortar can last a really long time. So,
if it's appropriate for the building.
Right.
Yeah.
Not in this kind of a building.
Not in
This
this
is
kind
all
of-
handmade
right.
brick from 1835.
Right. And this is like a gray bag mix.
Horrible.
It almost looks like something you would just buy at your hardware store. This mix really should have, even if it had cement in it, Portland cement, should have been a white Portland cement, not a gray. Portland cement's available in 2 colors. In old structure, if you're going to match it, you're usually using a white Portland cement.
And
That's
it's more
same color as the
expensive.
white. What's that?
And it's more expensive.
Right, it is a little bit more expensive, not a lot. Let me go back to that. So, does anyone know how deep you're supposed to prep a joint before you install mortar when you're repointing? So 2 to 2.5 times the joint width. So if you have a 1/2 inch wide joint, let's just say that's a 1/2 inch wide, it's supposed to be 1 to 1 1/4 inches deep. That's nowhere near that.
Right.
At all. Nowhere close. And you do that so that it will bond well, but it just lasts longer. There's a little bit more material back into that space. All right, preferred tools for removal, hammer and chisel or pneumatic chisels, so like an air-powered chisel. A company called Trowel and Holden makes that chisel sitting right there. They're wonderful tools, great people. They also make all the tools that go into that. It's a handheld chisel, so you're actually not holding a chisel and striking with a hammer. You're just using a little pneumatic chisel that just is kind of striking onto the chisel in the tool. They're fantastic. Center cut removal method. What that is using an angle grinder, which still should only be used in very skilled hands, someone that knows what they're doing. And what you're using is a diamond blade that is about a 1/16 of an inch wide. So if that joint is a 1/2 inch wide, I'm not using a 1/2 inch blade, I'm using one that's much thinner. I'm going right down the middle of the joint is what I'm doing, and then I'm getting out my hammer and chisels or pneumatic chisel. And what I've done by doing that center cut is create a relief, somewhere for the mortar to go. So I'm chiseling from the brick toward that relief that I cut, so it allows it to break away from the brick. An Arbortech tool, it is for soft mortars only, not for modern mortar removal. It actually looks like a couple little half-moon shaped blades with carbide teeth on it that run side by side just like this, and they go at very fast speed, and you can use them to plunge into the wall and it'll vibrate and it'll just cut those joints out. They're also great for the head joints, the smaller joints, because a grinder won't fit into those joints, but an Arbortech can go in there. Or if you're looking to remove one brick, it allows you to plunge and go all the way in and around that whole brick and just pull one brick out. It's a great tool. Silica protection, that must have been something that you added.
I did.
Per OSHA. That's something to keep in mind, that OSHA has put in pretty strict rules now for creating dust with cutting tools of any kind. So, and it's smart. There are a lot of people that have come down with some very serious lung issues due to the silica dust. So there are HEPA vacuum attachments for grinders. There are HEPA vacuum attachments for the Arbortech tools. Use those as well as the proper respiratory gear. So it says no grinders in inexperienced hands. Can anyone see why? Yeah. If you walk, or you'll see this now everywhere you go. You'll start to see this now that you know what happened.
So if you hire a mason and they show you that they did this to a building, run!
Yeah, they like to use them on those head joints too. And then they just overcut and just destroy the brick. Something else that you'll see fairly common, there was a project that we worked on, the Major's house. Warnell House. Warnell. In Kansas City, it's the Warnell House Museum. And we didn't know it until we went to do some repair work, but it had been 100% repointed at some point. Well, we had a serious drought condition for 8 or 9 years that caused a lot of foundation problems. So we were going in and we were doing some foundation underpinning and things like this. But we also had a corner of the house that we needed to deconstruct and rebuild because it just cracked and was falling away. So we're deconstructing this. Oh my goodness. We looked at the bricks on the facade of that house, and the mortar joint was maybe less than 1/4 of an inch wide in the historic brick on the interior, but it was over 1/2 of an inch wide on the exterior. Whenever it was repointed, they came through with a massive repointing grinder with a repointing wheel, and they overcut every joint on that whole building because those little joints are hard to mess with. They get tools in there, those little joints. So they just went in and created a whole new joint profile. So the outside, about an inch coming in was a good 1/2 inch or more tall and deep. And then once you got just inside that brick, it came down to the original. So they changed the entire appearance of the exterior of that building. You see a lot of mortar when you look at it now, whereas back then, you probably would have mostly seen the brick.
They had very skilled masons on that project that used really good, high quality brick. And the idea was to really minimize, that's part of the aesthetic of a house that has really good craftsmanship, is that very small mortar joints. So that was expensive brick for them to get at the time, and it's, a really good skilled mason, and somebody just came through and destroyed it. There's another house not far from there, the one that has a big fountain in it on 55th Street there. And they've done the same thing to that house, and they've used a really white mortar. And to me, it looks kind of like when you're, you know, looking at a giraffe and it's got all these spots, you know, it's just, you can see every joint from the street. It's ridiculous. So, you know, the mortar is supposed to be sacrificial and it is supposed to wear and be maintained, but it's also not supposed to be the critical element that you see. It's not supposed to be standing out. So, and we often find that in buildings, especially from the late 19th century, sometimes they even used a red mortar. And that red mortar, you know, was meant to make the wall look a little bit more uniform. So.
It's just kind of rehashing some of the things I already said there. Yeah, so removal of mortar should be by an experienced mason only. This is an excellent photograph to have here. So basically what this is showing, it almost looks like a mock-up preparation.
So that's John in the background. Spiewak.
Okay, John Spiewak.
Yeah.
Okay, so John Spiewak is in that picture. If you don't know who he is, he was the co-author of Preservation Brief for Historic Masonry for the National Park Service. Great resource. I consider him a friend. We talk quite often. So a mock-up is when you have someone come in and say, show me what you can do. But I'm not going to turn you loose on this whole structure until you show me you know what you're doing. So let's do a 4 foot by 4 foot area over here on this side of the building, and I'll approve it. Angie reviews mock-ups all the time, not just for masonry, for all types of products and construction. There's no reason a homeowner or private building owner can't do it yourself.
Right.
You know, do the same exact thing.
Ask for mock-up.
Right.
This is something we've talked with the Preservation Commission about. If you don't know how to answer a question, ask for mock-up. You know, don't approve something if you're not familiar with it yet. Let's see what it looks like. Let's make certain the person that's doing it is skilled, that they're going to give you what you're looking for at the end. What John's doing here is actually training to teach them how to remove lime putty mortar, and this is the Hickman house again with a really soft brick. So it took a lot of care to get that mortar out. It had not been repointed with a hard mortar, thankfully, so this was kind of a rare. Oh, this is really rare. Asking them, you know, to show that they knew how to use the tools without damaging the brick, and that they would know then how to. So they took the mortar out and these, cleaned them, and then repointed them for him. And everyone that worked on the project site before they were allowed to step foot on site had to do their own mock-up. It wasn't just the primary mason; it was all of them.
Yeah.
So.
And John was probably involved in that whole process.
Yep.
And he'll actually certify masons on
Right.
projects, be approved to be able to do the work.
That house, and I'll talk about it later, but because of its significance, we wanted to make certain that it had skilled labor.
Joint preparation. So clean out the joints with compressed air and a light water rinse. Being careful not to flood the wall cavity because you have opened it up now. So you might have delicate plaster on the interior or something like that. But you do want to rinse out that joint. You don't want a whole bunch of mortar dust or anything like that left behind. It'll prevent bonding. With joints greater than an inch, those deeper areas need to be filled first to create continuously even depth for pointing. When that usually when they're deeper than an inch, it's because there's like a hollow pocket, like something that hadn't been filled when it was first laid up. You know, we like to think that every mason back in the day was, you know, the ultimate craftsman, but they cut corners too. Okay, so you'll run into that. You'll see areas that are hollow up in there, and go ahead and fill those out and bring them out to a uniform depth without bringing it out to the face. So you're kind of prepping it for that next layer of mortar. And there's one reason that that's very, very important that I find, and it's only experience that teaches you this, is sometimes you'll, and this goes back 15 years for me because it just bit me. You pay for your education one way or another, but we didn't do that. We filled that whole thing full, we filled it all the way out to the surface, and the mortar color was different from one end of the building to the other, and it would vary across the joint. It all had to do with how much mortar we were putting. It just cured out different. The deeper joints cured out darker. The ones that were a little bit thinner cured out lighter. And you think, well, give it time, that moisture will get out. It's just wet, it's just more. No, it stayed that way. So we had to take it all back out, take it back to a flush, you know, even joint in the back of that cavity, and then point from there on out. So it's important for a couple of reasons. We talk about lifts, building out the joints in 1/4 inch to 1/2 inch lifts at a time. 1/2 inch definitely is probably a good guide. 1/4 inch I think might be a little small, but depends on the width of your joint as well. If you got really big wide joints, you don't want to pack a lot of mortar in there at once. Because what happens is, especially the softer, high line mortars, the more material you put in there, the more shrinkage or potential shrinkage cracking you could get within that material. Additional layers to be added when it's thumbprint hard. You don't want to cure, you don't want to get completely dry. You definitely don't want to finish on a Friday at that point without finishing your joints out flush. Once the final layer is applied, it can be tooled to match the historic joint. Hot or extremely dry climates, light water misting. Now when we say a water mist, it's a mist. So like you don't want to even take a garden hose with a sprayer on it. They almost are never misty enough, if that's a word, because you can quickly oversaturate your mortar to the point where now you have lime running down your building, and that's a mess. I mean, it's very difficult to get rid of. So if you ever remember those things you could hook up a garden hose to like sit on your patio, they were popular for a while. They just sat there and they had little bitty misting heads on them. They just, you know, you'll see them in restaurants in the South too, on the outdoor eating areas. That's what we're talking about, that fine of a mist. And another thing you can do is cover it up with burlap. And then just make sure the burlap's wet. If you need to leave overnight and it's really hot and dry, you can just lay burlap up over that wall, put a couple nails in somewhere, and that'll protect it as well. Mortar preparation, blend all the dry ingredients first. Especially important if you ever have to use a pigment or anything like that with your mortar. Prehydrate the mortar with just enough water to make it hold together, and then you mix it for about 5 minutes, and then you can add just a little bit more water to it until it's workable. If you rush the process, you'll find that while you start placing it into the wall, it's getting really dry and it's not workable any longer. So you actually do have to do the prehydrate and then wait about 5 minutes and add just a little bit more to get it to the point where it's workable and like you want. It's one that's moist enough to hold together, but not so moist that it leaves wet mortar smears all over the masonry. And that's important because you are not going to, on a historic building in front of Angie or I, ever do an acid wash or any kind of chemical wash after you're done. So no. All right, commission mortar. About the same thing, isn't it? Yeah. Lime putty. You mix with sand by volume. So lime putty mortar is, you can actually buy lime putty in 55-gallon drums, 5-gallon buckets. It's actually kind of moist. It's like a putty already. And you mix that with sand by volume, not weight, like we said. Now, let's see what this says to do. I'm trying to remember. So, the way I was taught, if you need to figure out what's the ratio, how much lime putty and sand, everyone says 1 to 3. That's a guide. So all sand is different. What you really want with a good lime and sand mortar formulation, if that's the area that your building is built within, is if you were to look at the mortar once it's cured under a microscope and you sliced it, you should see all the little sand particles completely touching each other, 100% touching each other. There should be no areas where those sand particles are floating out in the middle with lime all around it, okay? What you want is called fully consolidated. So where all the sand is together, it's all touching, and then the little voids, because sand is not perfect, it's kind of irregular shape, all the little voids are filled with lime. How to figure that out? Because all sand is different, sizes, shapes, and all that. So what we do is we take a 5-gallon bucket and we fill it up with sand. Then we take a 1-gallon bucket, or something has measured lines on it, and we put water in it. And we start pouring it into that bucket full of sand, okay? And we count, we measure, okay? And we get to a point where, let's say it's 2 buckets, end up bringing it up to the top of the sand. The water shows up, just right at the top of the sand. That's the exact quantity of lime putty I want to use. It's however much water it takes to get that sand filled up to the top. Okay, so now that's your ratio. It's two lime putties to 5-gallon bucket of sand. So that's what it comes down to. What's funny is you say, okay, I have a 5-gallon bucket of sand. After I add lime putty to it, how much mortar do I have? You got an answer? There you go. You have 5 gallons. You're like, well, that seems really weird. I've just added something to a 5-gallon bucket of sand and it didn't gain anything, but it's just because you fill the voids between all the sand particles with the line putty. So that's how you figure that out. Okay. Are we going to be doing a walk at all? after
We
this?
can if they want to, yeah.
If they want to?
Yeah.
Okay, I just don't want to take too much time. Okay, begin, you follow by placing line putty on the sand. So you basically have sand, you make a little dollop out of the middle of it like a volcano, drop your line putty into the middle of it. You can use a mallet, you can use a shovel, whatever, kind of stir it onto it. Then usually we take that and we put it into a tub of some kind, and then you can use a mortar hoe. We like to use a baseball bat or a softball bat and just mash it. One of our gals, Linda Scales, likes to get in there in rubber boots and do the old wine making dishes. So she just gets in there and she just stomps around something. So, but it's important to do a really thorough mixing with it as well. You can add Portland cement to lime putty and sand. You need to add it to the water, not directly into the putty, because it'll just clump up and you won't have a good mix. Okay. Carbonation. So this is kind of interesting. So when lime is made, it's basically you take limestone out of the earth and then you fire it in a kiln, and all the carbon atoms are escaping, all the moisture is escaping, and you're left with quicklime, which is basically just, it's the same size as the stone you put in there, but it may weigh a quarter of what it did before, after you end up firing it, and it'll be white, very white. So you've ran all the carbon out of it and all the water. That is then taken and slaked by adding water to it. And when you slake, you add water to that quicklime, it will actually boil. There's such a reaction with that water running home to mama. It creates a tremendous amount of friction and a chemical reaction that it'll actually physically start to boil just within 30 seconds to a minute of doing that. You can look it up on YouTube. It's fascinating to watch. It's really weird. Now, that is then stored in a putty state, usually for about a year, for a good quality lime putty, and then taken and added to the sand. So now you've got that lime putty and sand mixture you put into your building. Well, how does it set up? Well, the way it sets up now is by sucking carbon molecules out of the air into the mortar, and that process is called carbonation. That's the curing process. So it's not a moisture cure, it's not a chemical cure, it's actually just the carbon atoms running back into the mortar. It's probably the most green building material you can use if you really think about it. It's pulling carbon right out of the air. It's a very slow process. One thing you can do to speed it up is to use a churn brush, which I mentioned a little bit ago, which is down the bottom right. Once the material has kind of gotten to a thumbprint hardness, you take that and you can see that those bristles are angled. And yeah, it's called a churn brush because it was used to clean out butter churns. They're actually made in England, I think. It's where we get them. That angle allows the bristle to flex a little bit instead of just going straight into the mortar joint. So when you slap that mortar joint with it, it's not only pressing your mortar in and compressing it a little bit better, but it's also taking that little striped slurry face off of the mortar and it's exposing the sand, and it'll give it a little bit more of a textured appearance that allows carbon molecules to get into the mortar a little bit better. So it helps with the carbonation process. Clean. You want to talk about cleaning?
Sure.
Just a little bit.
That's fine. So for masonry cleaning, appropriate cleaning can be good for your building, and it can also, if it's inappropriate, can cause permanent damage. The reasons we clean a building is to make it look better for appearance, to stop or slow deterioration, and to provide a clean surface. And what I mean by clean surface is not just to make it look better, but sometimes you might want to repoint your building, and having it clean makes the repointing a little bit easier. You might want to clean it because you need to add some type of water repellent or a sealer or consolidant to the building. So there are a lot of different reasons that you may want to clean, including paint removal. So you identify what needs to be removed, test different options, and always look for the gentlest means. So if you can clean it with water and maybe a little scrubbing or a little bit of very light detergent, that's always the best way to go. If you need to get into more of a chemical, you're going to test that. You're going to do it with somebody that knows what they're doing. They're going to do test panels for you, make certain they're not damaging, the stone or the brick while they're doing it. And, generally abrasive cleaning is just not appropriate for a historic building. This is a building I'm working on right now in Leavenworth at the VA hospital. This was sandblasted. The building had been painted white. All of the buildings on the campus had been painted white. That was just kind of the thing they did in the 1940s and 50s to make everything look a little bit more contemporary. And they kind of came through here in the 80s and sandblasted all the buildings thinking they were restoring them. And what they did was actually take the surface off of all the bricks. And so you can go around here because these bricks were soft in certain areas, some might be harder, some might be softer. So what somebody's taking their sandblasting wand across here, and every brick has a different hardness to it, so they're pitted. They're pitted differently.
Varies, yeah.
So you can see that you walk up to this building and the shadow lines are really bad. This is irreversible, obviously. It's taking the fire skin off the brick, and the brick now is a sponge, so it just absorbs water. So they have a lot of issues with plaster on the inside of this building because it's direct plastered onto the brick on the inside face. There's lots of bubbling, and they're like, why? Well, I can't imagine. They're getting a lot of water in here.
So when this happens,
Uh-huh.
do you have to repaint it if there's no other option?
They don't repaint it, they choose to put a water repellent on it. So, and that in this case is probably the best option.
You say water repellent?
It's a water repellent, yeah. And that has to be applied every 7 to 15 years depending on how it absorbs, how far it absorbs. And we can talk about that a little bit more. Different bricks absorb different things better. So this also, during some of their restoration work, they did a lot of brick replacement here. And, they didn't bother to match. I guess in order to match it, you'd have to go out and sandblast a bunch of brick to put back in here. But the building is very, uneven looking. So this to me is kind of a restoration fail and something that we don't ever want to replicate.
It was very common.
Oh, I think I told some of you when I was here last time that as a kid, I think, I'm a restoration architect because I like history and genealogy and I love old buildings. But I remember I grew up 2 blocks from the courthouse I grew up in Maryville. And I remember riding my bike up there and sitting across the street from the courthouse and they had it all scaffolded and it was just like a dust cloud around the building, big, red dust clouds. I never sandblasted the building and when they were done, I thought, that looked pretty amazing. I want to do that,
That looks
and
great.
It looks great. And needless to say, they were sandblasting the face right off the brick, just like this. So it creates a lot more maintenance later. So, with masonry repairs, there's also a lot of other things we look at. It's not just mortar. And we don't have time to go through every one of these today. But real quick, mortar analysis is really important. You can do the more hardcore, literally, mortar analysis where they're getting into the nitty-gritty of it, or you can do just an acid digestion that shows you what the aggregates look like, and they can show you kind of what those proportions are. And that's something that can be done locally. And sometimes even this Black and Brick can do the real basic ones. Stone and brick patching, what this means is, like, let's say you're missing a part of a brick or a part of a stone. There are breathable patching materials that are appropriate. There are also super inappropriate patching materials that have a lot of Portland in them that you don't want to be putting on your buildings. The picture I showed you of the Church of St. Mary Aldermanbury, the one that came over from London, had a lot of really old stone patches on there, and they are some type of Portland product that was done probably very early in the 20th century. And we've chosen to leave them because they're part of the history of the building, but we don't do that today. Today we work with a couple of different companies. There's 3 or 4 here in the United States that can color those patches to match exactly the material you're working on. So they can match one to your brick color, or you can stain the brick later if the patch color isn't quite right. Or you can, order the stone colors and to do this. I think this is the first project Corey and I worked on together like 14 years ago. This is the Black Archives. It's down in Parade Park in Kansas City. And a lot of the stones here, first of all, they repointed the building with too much Portland cement. The whole building's repointed in Portland. It's very hard. The stone here is just kind of a vernacular, just field stone that they used. It's not a really good high quality quarried stone. This was just meant to be a maintenance building. And I'd say, I don't know, a fifth of the stones on here almost needed patching of some type or replacement. Some of them were replaced, some of them we chose to patch. Mostly because we didn't want to get
400 5-gallon buckets of patching material.
right.
on that building.
And it took, so US Heritage came down, we did a training session on the patching, and it's not like we ordered 400 buckets of the same color, there were 400 buckets of 4 or 5 colors.
Right.
So they were blended. So each one of these stone pieces is a little piece of art, and I loved watching him. Corey had a really good group of guys that were on here, and each piece took love. You know, they build it up, they make sure they've got the colors done. This is one is still kind of wet, but they did dry out. You guys, you cannot walk up to the building today, 13, 14 years later, and see the stone patches. They're pretty amazing. So it's an art. So we've also got masonry staining, like I said, you can get different colors to make your bricks look like a million different things, and these absorb really well. They're good, long-lasting options, especially if you can't get a good match to your brick. So let's say you have a yellow brick that has an interesting texture, and you can find a red brick with that texture, you can actually stain it to match the color that you need it to. And there's a whole company that makes those types of stains. Cleaning, we've talked about, there's lots of different types of cleaners out there. Always use the gentlest means, try to avoid the chemicals where possible. Sealing is another thing. You know, sometimes we're using a consolidant and a sealer, and other times it's a sealer. Whatever you do, you don't want to put a sealer on there that's not going to breathe. I had somebody tell me the other day, I put a sealer on my building, and the water just drips down the sides. And so it's not a deck. You want your building to breathe. You know, remember we talked about getting those moisture vapors through your wall. If you seal it on the outside face and it's not breathable, you're trapping that moisture. It's going to do as much damage to your wall as not sealing it.
And the way that those clear sealers work is it creates like a surface tension so that, you know, raindrop particle size moisture will hit it and run down. But moisture within the wall cavity is a vapor, and it can move through that from the interior out. That's how a breathable clear sealer works.
And there are a lot of products out there, and they've got firm ratings, and you're going to want to read about those before you put them on. Make sure it's appropriate for your building. Consolidation we just talked about. Helical anchors are another thing we use a lot in masonry. That's what you're seeing put in here. It looks like a really giant long drill bit. They're a stainless steel product that we put in to essentially stitch cracks together in masonry. So sometimes it you know, just isn't viable for you to relay a large section of a wall, and sometimes we'll stitch them together. We call it stitching with these helical anchors.
It doesn't bring the wall together, it just stabilizes it in its current condition, so it doesn't get any worse.
We do dispersed hydrated lime injections. We do that a lot in like a limestone material where we have really fine little cracks that we want to fill, make certain we don't get freeze thawed into those stones, just to help preserve them a little bit longer. And injection grouts are something that we do in multi-white masonry walls, where we might have the rubble backup and a veneer on the face, and sometimes, like he said, the voids in there either get washed out over time, or maybe it was never tied in together very well to begin with, and we can do a combination of stabilization and grouting for those walls too. This is the Hickman House. This is over in New Franklin. This is a project we did many years ago now. Built in 1819, all handmade brick. The brick was made on site, fired on site. So very, very soft. It's a 3-wide wall. And at some point, I'm going to say probably around late 1800s, early 1900s, somebody came with it. But it was with a very hard lime-based paint. And that paint has baked onto this brick over time. So it wasn't like a latex paint or an oil paint or something like that to remove. This is a lime paint. And we have pictures of it really early, in the 20s and 30s. And throat is dry. So in order to get this off, we had to test a lot of different materials to get this lime off. And this is Craig Freeze, and at the time they were repping a lot of different products that we were using and testing. So we did a lot of test panels to make certain that when we removed it, we still ended up with a natural brick that, you know, we weren't altering the overall color. I will tell you that, you know, the finished product out here looks really good. There's still remnants of that old lime paint on there. We chose to just kind of leave it instead of trying to make this perfect. That was never the goal. The goal was to get it at least to make it look like a building. You know, we restored a lot of the original window, and you know, this was not an original opening, so here it's infilled, and restored some of the other door and window openings that had been changed over time. This is a good example of what a mock-up does for you, and you can watch and see how they last over time. This is Liberty Memorial, the stone, the south wall. at the entry, where we did a stone cleaning test area before we cleaned it. This is during the BioClean work. I should say that this is not one of the historic walls. This is the wall that was built when I built the museum. And it's battered, which means it's sloped slightly. And the battered wall catches all of the biological debris in the air and just holds it. So this wall just gets dirty really, really fast. And it sits in all of those little crevices in the limestone and just balloons everywhere. So it's very unsightly when it's dirty. It makes it look like they don't take care of the memorial. So what we've done is we've actually gone through, I don't normally like to do a sealer on limestone, but in this case we did, and it helps wash that wall a little bit better and keep the rain particles, and it keeps some of that biological growth from growing. But we were able to do test areas here and prove, you know, that we were doing something that we were going to be really happy comparing that to the control. So this is something now that they renew. We'll clean it again probably in a couple of years and another application. So I was just quickly going to run you through another example where we were able to use a lot of contemporary materials and some substitute materials along with the old during the restoration. This is the General's Wall. I don't know if you've ever seen this, but it's down in front of the Marine Memorial. Faces Union Station. So the block fountain's kind of in front, and then this is at the base of the hill right there. These are the 5 generals from World War I, from the Allied forces. I think most of these generals were here when the Marine Memorial was dedicated, and this is a wall to dedicate that. This is an 8-inch thick stone. They are all hand carved, and they're not carved in. These are projecting letters, which is a really unusual way of dealing with stone. There are no records really of the actual construction of this wall as to where they got the stone. So we went through months and months of trying to stone match this. We ended up finding a quarry down in Kansas. It's called Bandera, and that's the stone that we were able to use. That's a pretty close match. We had to recarve a lot of these. So this is built into the hillside. The backside of the wall was never waterproofed. So it has a concrete backup here, but this is old board formed concrete. It's very porous with no waterproofing on the backside. And the whole hillside runs down the back behind this. And they tried at one point to put an inlet back behind to stop some of the water, but eventually it still creeps in. So there was a lot of stone loss, a lot of sloughing, a lot of erosion of the stones. We replaced about 1/3 of the stones in this wall and have them all hand carved. This is one where we had to go back and restore all of the bronzes and clean up the metallic staining from the stone. And there's also tablets over on the other side. So the busts and the tablets, we did both of those. And this is what it looks like finished.
So what do you use to clean the bronze?
You know what, we send this out to Mid-American Metals actually did these. They stripped down all of the coatings and the waxes and everything that had been used over time. They put kind of an acid wash on it, and then they repatina them to the color that they're looking for. So we repatinaed these instead of to that coppery color, which is what comes out after it's been sitting like that. And when they're not protected like this, they tend to get really pitted. By taking it back to this, then we've also put a protective coating on them so that they don't have to wax them every year. So that's actually patina to get it to kind of that nice brown rich color, and we can highlight, some of the different features on the faces and on the letters when we do that. So this is a finished product, and we really have a hard time telling where the replacement stones are. We were able to get really good graining pattern and colors, but we also were able to dig back behind, waterproof the wall. We put flashing in this wall, which it's never had. We put weeps in the wall, which it never had. So there are things we can do to improve that historic construction over time. Maybe we just thought about this being a freestanding wall instead of everything that's coming in from back behind. The other thing that we did here was that this sidewalk gets a lot of silt, and the base here we actually added a granite at the base. That's something else that they had taken the limestone all the way down to the sidewalk. Not something I would do on major historic buildings, but for here, this is a huge maintenance issue for them, and to go down and put limestone back at grade where they're salting is not a good option. It'll just get destroyed again. We did this on some of the new planters up top too that had limestone that came into contact with grade. So that's a close-up of a lot of the new and the old kind of mixed together. Like I said, we've been doing a lot of work on Liberty Memorial over the years. A majority of what we're doing here is in-kind replacement. We actually work with the quarries to make certain that we're getting stone units that are rusticated, is what it's called. It's a rustic limestone, which comes from different parts of the quarry, and the colors all match and blend really well. We've replaced the signage on that front entry multiple times, because I keep changing the name. This is the last rendition, and hopefully this is how it stays. But this is that battered wall. And this is, I'm going to say, 3 years after we cleaned it, so it's still looking pretty good here, maybe 4 years.
That's great.
Yeah. This is an example of what our survey drawings look like. This is the north frieze on the north side. So we get in there and we look at, this is the only way they know how to actually put a price to it, is by where do we need to remove patches, where do we need to put new sealants, and where do we need to put expansion joints, and what do they look like? Where's mortar missing? We even had one place here on the north frieze where the original carver had gotten too deep and actually went through the back of the stone. So we were able to patch that a little bit to keep water out of the wall. And we've added new flashing in the walls to kind of keep water out of the north frieze. And we kind of invented a system here with a flashing company that hadn't been done before that will give them some flexibility and longevity, where we can maintain mortar in those joints as opposed to sealants, because we're finding that sealants aren't getting replaced. They take a lot more work for maintenance. Again, this is the Hickman. I don't know why I have it here twice. Sorry.
You're proud of that.
I love this project.
Yeah.
It's pretty
You should be proud.
This is a good example of what it looks like on the inside when you have the plaster directly over the brick, where that system breathes. So when we went through and restored the plaster walls, you can see that we were able to kind of stitch it in, so that gets bonded back to the brick after we've made the repairs. All the fireplace openings in here have been changed over time. The sizes have been changed. And so we wanted to go back to the original masonry openings. This is a good project to talk about as well. This is Unity Tower. We did a full interior and exterior rehab on this. The upper units up here are a really unique cast stone material and had just literally the cementitious binding was just coming out of it. They had not been well maintained. There was a lot of water back behind them. We did a significant amount of replacement of the cast stone units and the balusters at the top of the tower up here. And then the travertine at the base is actually material that we ended up having to get from Mexico. It was very unique. You can talk about a couple of projects.
Yeah, the Woodneath Homestead. So this is the one in it's actually Kansas City, but it's Westfield Lakes, Liberty. This has been done in two phases. We're actually in the second phase right now. Actually, I should call it like 4 phases. I started looking at this project almost 10 years ago as a consultant to help with the scope of work on it, to help Trudy and their firm with trying to decide what it is that it needed. So we initially did the exterior restoration of this building, which included everything from the porches to the shutters. We took the shutters off, completely built all brand new shutters to duplicate the originals. They're all built out of mahogany and then painted so that they would weather well. Got a 100% repoint. There had been a lot of past repoint campaigns with all types of mortar on the building that just wasn't performing well. It's holding water everywhere. And that's actually a couple of our guys up there. I think right after we had taken the windows out, and they're actually stripping some of the soffit, I believe, in that area there.
And this is listed locally because it's in KCMO. It does go through landmarks, so all of the work, kind of like you guys have here with your Historic Preservation Commission, goes through the city for review.
Right. So the exterior is done for the most part, and now we're moving into the second phase, which is all the interior restoration work, which includes all mechanical and electrical systems, low voltage wiring. They're going to do all kinds of fancy keypads at all the doors so that they can reserve them and show who has this room. It's actually, I didn't mention, it's being turned into the National Storytelling Center for the area, so it's kind of a big thing. We're going to have people that come in from all over the country. They're professional storytellers work within the space. This is actually Fort Larned in Kansas, kind of near Great Bend. This is actually a sandstone building built in the 1860s. It was a fort for only about 3 years during the westward expansion of the United States, and It served its purpose. There are 9 buildings out there. They're all constructed on their original sites. They're all still there. None of them were torn down, rebuilt, moved, anything like that. And I don't know if you can tell, if you look really close at the sandstone, you actually see carvings in it, which we consider graffiti. So they're actually hand carved with spoons or pocket knives, whatever, names of a lot of the different soldiers that were based there on that fort during that time. So they consider that a very important part of the site, and their buildings are now all consolidated. If you don't know what consolidant is, it's a product that is added to a stone or a brick or a substrate that needs densified or strengthened in some way. Consolidant will penetrate that stone, and then it will harden. It will fill some of the voids within it, and it'll make the material much harder than it is today. And being sandstone, they were afraid that just natural erosion and wear, they would lose all of that graffiti from, from 150, 60 years ago. So that's a corner of the wall that was failing. We rebuilt it. It did not look like the left side when we got a hold of it. There was just big cracks in it. So that's kind of showing the mid project photograph on the left, and then the post photograph on the right. And the question was asked earlier, do you number stones if you're reusing them or whatever? We do. And actually on stone buildings like this, we've done another thing as well, where we actually hang heavy plastic over the exterior, and then we actually trace out all the mortar joints, and we physically write on there with a big fat tip Sharpie numbers on all of those, and we photograph all of them. That allows us to not have to actually put some kind of a number on the stone itself. Some people will tag them with a metal tag or something like that on the backside. It's worked a lot better for us. This is actually down in Wichita, Kansas. It's a historic neighborhood called Belmont Place. They have these historic, beautiful entrances that are actually, the bases are Carthage limestone, or Carthage marble, which is actually a limestone, which aren't faring well, Angie, big surprise.
Right.
On very busy streets, and they were just, the stones fracturing. One of them, the foundation failed. We're rebuilding it here on the left. But we restored that about 10, 12 years ago, and we're going to go back and do a little bit of cleaning and spot pointing here this fall. So just a little bit of maintenance work. That's a situation where the neighborhood association actually does inspect the arches about once a year, but they knew it was time. So they're bringing us back now so that they don't have to spend $300,000, which is what it costs them. Then they're going to spend about $20,000 with us now as a maintenance. Cold storage lofts is downtown Kansas City. We did all the masonry restoration on this project, as well as all the steel window restoration in this little courtyard here. It's the first project our company ever did. How we got a project that big, never doing historic restoration work before, I don't know. But the owner trusted us. We must have been cheap. Maybe that was it. We must have been cheap. But we did have a good contractor we were working with that kept a close eye on us, so we learned a lot on that project. And then this is one that Angie mentioned a little bit ago. This is the one that had the stone patch, where we used 400 buckets of patching material on it. And you're exactly right. It's one of those things where that can either go really bad or it can go really good. Like, you could walk up and it just looked like pimples all over the building from poor patching, to where this one, it blends in really, really well. It's one that we're very proud of today.
And even today, I have a hard time walking up and finding one.
Yeah, so given the way that patching material works, they actually would apply sometimes 3 colors on one stone.
Yeah.
So they would apply a layer, maybe a ½ inch thick of one color, then another of a darker color, and then another of a lighter color. And then they let it set up just a little bit, and then they have sculpting tools, and then they just kind of shave it away, and it would reveal little veins within it that duplicated some of those colors that existed in the stones. And it really was artistry. It came out wonderful. And then the soldiers and sailors. So that monument, if you've ever been to Des Moines, Iowa, it's just on the south side of the Capitol building. It's beautiful. Built in what year? Late 1800s. Granite.
All granite.
140 feet tall. How'd they do it, right? They actually ran a railroad spur up there, didn't they, Angie? Isn't that right?
Yeah.
Up the hill and up to that point. And I think they actually used the railroad and some type of a hoisting system with the scaffolding to pull those stones up and stack them one by one.
There are only a handful of monuments from this time period like this, and this is, I think there's one in Indianapolis, and there's one other that we looked at that were similar scale. This is a Vermont granite, and they bush hammered every piece on the lower section to give it this really nice texture. And over the last 100 and some years, it's actually had micro cracks in it and freeze thaw. There is a lot worse than even what we have here, and it is sloughing off in big chunks all over. And really, there's no way to fix it. You can't consolidate granite. So it's a matter of getting in and trying to clean it up and make it look as nice as possible. Repoint the joints, keep the water out.
Patch it.
Patch it. Yeah. You can't.
Patching granite is pretty tough.
Yeah. Otherwise, you have to have a mason come in and actually resurface it, and then the process starts all over again. So bush hammering on granite is not a recommended finish for the Midwest.
No, not at all. And then this is in Topeka. This is the oldest cemetery in the state of Kansas. They have a section called Mausoleum Row that is just falling apart. It's earthen on the backside. So if you walk around the back, you can actually walk up onto the top of those mausoleums. It has a lot of marble. They were just falling apart. This is just some of the before and afters there.
And
Top to bottom.
we did 3 of these, and you did even the metal doors, but this was paid for through a heritage. The Kansas has the Heritage Trust Fund grant, and so that helped pay for the masonry restoration work here.
Right. That's it. Good. I think that's the last slide. Nope, there it is. And then cemetery, we also do cemetery restoration. This is actually in New Orleans. It's Chalmette, right after Hurricane Katrina went through. The cemetery is sitting under about 12 feet of water. It's right on the banks of the Mississippi River. There were cars, houses, everything you can imagine floating through this national cemetery. And it was breaking headstones, snapping them off, displacing them. We went through and repaired, and you can tell from the top to the bottom, there's a restored one, there's a restored one, there's a restored one. You can just tell by the color differences from this photo to that. But that was probably one of the most rewarding projects I was ever involved in. It was pretty neat. So when our guys would pull a headstone to be repaired, they took a full-size American flag and pinned it to the ground in that location. They really felt it, I guess I would say. Any questions?
We do have at the end of this a lot of resources, so I think we can work kind of like what we're doing with the design guidelines. Once this is posted, we can make a lot of these clicks live so that you can go directly to get to them.
What, we have, the museum building has the elastomeric paint on it. What do you do to?
Right, so he's got the museum building, they've got the museum building that's right around the corner.
Okay.
Up here, and it's a limestone building that has big painted over it. It probably should just be stripped and cleaned.
There's soft brick behind it, I'm pretty sure.
Right. Yeah, sometimes I want to know why. You know, how did it end up with elastomeric paint on it?
Usually-
You know what the
usually-
reason for that was.
Yeah, I know. A lot of people are like, oh, I'm going to paint my building because it's got these gaps in between the bricks. And I'm like, well, paint is not a substitute for mortar. So.
I wish it was. Well, that'd be easy.
But it's really, it does not do the same thing. Throwing elastomeric paint over deteriorating mortar joints will not fix the problem. So it eventually will crack and we get water back in. So.
Yeah, and the challenge with like elastomerics is that it's fantastic when it's first applied. It will keep the water out. There's no doubt about it. But if and when, it's really a when thing, right? Moisture does get behind it. It's 100% not breathable. There's no vapor.
We'll find
coming out
bubbles
there.
and cracks, and then the masonry right behind it tends to literally disintegrate the cover. So, yeah.
I have had people, knowing, because they know I'm on historic preservation commission, ask me questions that I really don't know where to send them for information and so forth. One example is a building across the street. It had, I don't know what it is, a white, like, concrete put on it. And I was asked by one of the owners a while back, should we chip that all off or should we apply more? that cement stuff to cover the brick, should be sandblasted, you know. I told them to come talk to Melinda, but I think so many people just have no idea. They heard that somebody did this or this, and they go ahead and do it and make things worse.
Right.
And being on the commission, I feel very inadequate to advise them.
Yeah, so she's asking, you know, how do you give advice to someone if you don't necessarily know the exact answer, so that you're not doing more harm than good? Melinda, Laura, Logan, and I have talked about this before. You know, in those instances where it's not just common knowledge, you know, about typical masonry stuff, we're here as a resource, and I've told them we can do hourly consulting to come up and meet with building owners so that they're not doing more damage. Sometimes I can handle those issues. Other times I might call somebody like Corey and say, hey, let's take a piece of this off. You know, it's not a cut and dry. Every building has different treatments for a different reason, right? Sometimes it was just because it was quick and cheap, and other times it's because it's covering some kind of sin. You know, maybe something else. And we don't know unless you get in and take it off. And, you know, we've had people remove stucco from buildings and they look great, and we've had people remove stucco from buildings and they look really bad. Sometimes they would damage the brick and create pits in it or the stone to get the stucco to adhere better. So you never know. You can't just give a blanket. You can't just give a blanket answer without doing a little bit more research and maybe some destructive testing and investigation work in order to tell.
Just a quick question, was that wall originally an interior wall of the building? Was there a building that used to be right next to it?
There was a building that was there,
Same.
but I don't know exactly.
Yeah. So we do see that a lot. Like when you see the buildings in the downtown areas that are falling or collapse overnight, they're usually built with that really soft brick. So
Kind of orange.
the interior walls, we call them salmon because they look different than the brick on the outside of the building. So if you can imagine the multi-white brick walls, so the ones that are made up of lots of different bricks, right? Let's say there's 3 different layers of brick. The outside might have a harder fired finish on the brick. And then the inside, 2 whites, 2 rows, and then tying together with headers, might be that softer brick. And they would put them often in between buildings if they knew that the next building was going up.
And it wasn't designed for exterior exposure.
Exactly.
Yeah.
Those soft bricks should never be put on the outside of the building. So if they are, it is appropriate to maybe think about putting some type of system over it that's going to help protect and waterproof it, whether it's a stucco or something like that.
So from a practical standpoint, if I'm in that position, they can, I send them here, is that?
Yeah.
Yes.
And they know they can call a number of resources. They can call us. If I don't know the answer, I'll put them in touch with someone that can.
Now, I have a second question. If you know that a building has damage and is deteriorating, how far can historic preservation go to addressing that, to contacting the owners and saying you've got a problem? Or do we just have to wait for them to come to us?
Okay. So she's asking what happens if there's a building that is deteriorating and there's obvious maintenance issues. What is the protocol? You know, what can Historic Preservation Commission do about those structures? I'm going to let Melinda answer that because I think it's a zoning maintenance issue.
It is a zoning and maintenance issue, and what it means is, in cases like that, you would actually call the Community Development Department, and we would start a process that doesn't necessarily include historic preservation. We'll incorporate you in at some point, but we're going to first start with the homeowner or the property owner, have the conversation about the damage that we're observing, and we may go after it with a code enforcement issue. Because our code department has a dangerous building ordinance that we can follow that will allow us to work with that. And we try not to go directly to dangerous building, but rather to find another way to find a positive outcome. Because we don't want to be adversarial from the beginning. We want to start with what's required, how can you make that work, what resources are there that can help you to make that work better. And so we'll start that process from that perspective. But always feel free to call community development and we'll work on it for you. and with you.
It's a good question. I've got some other pictures to pop up here real quick too. I forgot, yeah. Dennis sent a couple, and then this is from Lisa, right? Is this like a retaining wall? Okay. Is it veneer stone? Okay. I have a feeling, so sometimes with veneer stone you can literally epoxy them back together, and there are stone epoxies that you can use. So you could try that.
It has a concrete wall behind it.
Yeah.
Right.
So you could pop those pieces out, try epoxying them back together, put them back, because they're not structural.
Okay.
Or just literally pop them out and put a new one in if you can find that material or if it's something that you can get. But since they're not structural, it's not hurting the wall, but I know from an aesthetic standpoint, I think epoxy is probably the way to go.
It would be, yeah, a manufacturer to look at might be like bond stone is a good one. Or actually, they're concrete. These are actually concrete.
Yeah, they look like
So
it.
you might be able to use just like a Sika epoxy available at Home Depot of all places. It looks like a regular caulk tube, and it has a mixing nozzle on the tip of it. So just follow the instructions. But what you want to be careful of is don't place it very close to the surface at all. Get that nozzle way back in there to do it, because when you pull that together, you could end up with just a mess on this outside edge. It would look horrible. But if you can do it in the back side, inject it into the back portion of that unit, pull it together, it may not come out to the surface, and then those surfaces may just mate together.
Kind
You may
of
not even
salt
see them.
peel basically.
Right.
Okay.
But if that epoxy uses out to the edge, it looks horrible. You'll smear it with something, it'll make it worse. And yeah. Yep. But that's a good candidate for that. You're right.
Yeah. And Dennis, this is what you said, right? I had a hard time telling where the detailed shots were from.
Well, the picture I sent was of the garage back.
Oh, okay. Let's go to the.
Is there another one?
Yeah.
Okay. Gotcha.
Yeah, where that's kind of delaminated, I guess you call
Okay.
it.
So this is typical erosion, essentially.
Right.
So this is like a fieldstone, like what we were talking about, like the black rock pipes is made out of, and that how we know that is, see that clay color in it, that kind of darker orange and yellow. That means there's a lot of clay, not a lot of binder. And those are inherently weak spots in that stone. There's not a lot you can do for this except either replace the stone unit or do patching material.
Right. Right.
They're small enough that you could probably throw a couple of patches in there if it's really bothering you from an aesthetic standpoint. But if from a structural standpoint, there's not enough bond that I would be worried about it.
So where is this on the home then?
It's on the garage, he's saying.
Oh, the garage.
Okay.
Okay.
Is that over a door? Like
Yeah.
a hand door?
Doorway. Right.
But there's not a lot you can do with those. They're not worth consolidating because the clay in them won't absorb enough of the consolidation to make a difference. So really patching or replacement.
Okay.
is gonna be it.
Were any of the patching manufacturers in those resources?
Don't know that, I don't think so, no, but I could add some of that in there before I give them the final.
Might be a bad idea. I could send you some things, Steve, maybe a few materials.
Okay.
Add to it.
Yeah, we could do a materials page.
Yeah, something, and when we say patching material, you're like, oh, that's the company that sells the
Yeah.
patching.
Right.
Yeah, that'd be great.
There are a
Yeah.
couple of them out there, so.
Okay.
Yeah, because a lot of the, frankly, most of the products that we use doing what we do are not available at your local home centers. So, and they don't even know usually where to find them if you go ask them about them. It's just a different world that we live within, of course. So there are specialty manufacturers that you have to find.
Yeah.
Right.
Yeah, so I know we touched on a lot of things, very high level, but, you know, we could do an entire workshop on just mortar and another one on just line cutting mortar. And, you know, just keep going. But,
That's right.
I thought this would at least give a brief introduction to kind of what we look at on a regular basis when we look at these buildings. And I think hopefully give you some of the language to be able to talk with contractors about what you're looking for.
Very helpful, thank you very much.
Yeah. Thank you.